Hi, I have a lesson here to help you with the quotient of powers rules. In other words, if we're dividing monomials, how do we simplify those? And we'll go through some examples to help you with that. But before we actually get to that, I just want to look at this and go, can we simplify this without me teaching you some rule so that we understand where it comes from? And I look at a to the second divided by a. Well, what does a to the second really mean? Well, a to the second really means a times a, and then we're going to divide that by a. Well, I look at this now and go, oh, I have common factors in the numerator and denominator. There's an a in the numerator and an a in the denominator. Those are going to divide out and become 1. Therefore, my final answer is a, or a to the first power. Now, my second one, I have y to the 10th. Well, what does y to the 10th really mean? It means y times itself 10 times. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 y's. Then I'm going to divide that by y to the third. Well, that's 1, 2, and 3 y's. And then I can look at this and go, well, there's things that will divide out. There's common factors in the numerator and denominator. I think that's pretty obvious in this case. I have this y and this y can divide out and become 1. This y and this y divide out and become 1. And this y divide out and become 1. Well, then what's left? I have 1, 2, 3, 4, 5, 6, 7 y's left in that numerator. Therefore, I have y to the 7th power. And then my last example, a couple different ways to look at this. I have 4 to the third times 4 to the 5th. Some of you might look at this and go, well, 4 to the third is 64. 4 to the 5th is 256. I get those. And then in the denominator, oh, no, not 256. That's 4 to the 4th. That would be my denominator. I'm jumping ahead of myself. This is 256. But that 4 to the 5th, that's 1,024. For those of you that are good at multiplying 4s in your head very quickly. But now we look at this and go, well, can I simplify anything here? Well, the answer is yes. There's lots of different things that we can simplify. I would start looking at this going, well, 64 will go into 256 4 times. So I can look at this is going to divide by 64 and become 1. This is going to divide by 256 and become 4. But then I would look at it and go, well, 4 goes into 1,024. So the 4 divided by 4 is 1. 1,024 divided by 4 is 256. And then that would leave us with a final answer of, well, 1 times 256 in the numerator is 256. There's just a 1 in the denominator. So right there's our answer. Now, another way that in my mind would be a little easier to work through, because then I don't have to do as much multiplying, I'm just going to start off and go, well, this 4 to the third, let's just do this. I'm going to clone that, and then we can rewrite it here. Perfect. So when I look at this, I look at the 4 to the third. Well, that's 1, 2, and 3. And then I have to multiply that by 4 to the 5th. Well, 4 to the 5th is 5 4s. And there's 5 4s. And then we have to divide that. Let's just move that up a little bit, make it easier to see, by 4 to the 4th. So that means we have 4 4s. And now that I'm at this point, this is where I would look at it and go, well, let's get things to divide out of the numerator and the denominator. 4 here and a 4 here. Both become 1s. These 4s divide out and become 1s. These 4s will divide out and become 1s. And these 4s will divide out and become 1s. So now I'm left with, let's go like this. I'm going to be left with 4 to, well, what power? There's 1, 2, 3, and 4 of them. And 4 to the 4th is equal to 256. So this way, I only have to do that 4 times 4 times 4 times 4 once in my head, instead of to get to 64, to get to 1,024, and to get to 256. So I like that approach a little bit better. Now, here's the thing. How can we use what we just did here and apply it to the quotient of power rule? Well, what this one says is, if you have two monomials, a to the m and a to the n, and you're dividing them, then we get to take those two exponents, and before we get there, I'm going to come back here and go, well, notice the exponent on this one, we had a 2 and a 1, and our final answer had a to the first power. In this one, we had an exponent of 10 and 3, and in the end, we had an exponent of 7. This one, I like the second example because now I can look at this and think a little bit about what you've learned about the product of powers rules, where here we have the 3 and the 5. So really you can think of that numerator as 4 to the 8th power over 4 to the 4th. And then we ended up with this 4 to the 4th, which then we converted to 256. But hopefully some of you are recognizing that, well, we're just taking those exponents and we're subtracting them. And that is right. So to simplify this little division problem, to start at the beginning, we're just going to take those two exponents and subtract them. Now notice, we took the numerator minus the denominator, and then our answer was in the numerator. Okay? So keep that in mind now as we go through and we simplify these expressions. So the first thing I'm going to do in our first example, the orange one, is I'm going to look at the numbers. So I have a 5 and I have a 10. Maybe I won't circle them because I'm going to look at this and go, well, if I have a 5 in the numerator and 10 in the denominator, both are divisible by 5. That 5 is going to become 1, and that 10 is going to become 2. So I know that I'm going to have a 2 in the denominator for sure. If there's only a 1 in the numerator, I'll put that in later. The next thing I'm going to do is I'm going to look at the c's. Well, I now have c to the 6th over c to the 4th. Remember, since we're dividing the c's, we can subtract the exponents. I always like to look at the larger exponent, subtract the smaller one. 6 minus 4 is 2. Since I started in the numerator, my c's are going to remain in the numerator, and I'm going to have c to the 2nd. And I think about it, well, if I had 6 c's in the numerator, 4 c's in the denominator, I'm going to divide 4 of those c's out of numerator and denominator. There's going to be 2 left in the numerator, none in the denominator. That's why c to the 2nd is in the numerator. And then last but not least, we're going to have this d. Well, that's all by itself, so d just remains here. And then my final answer is going to be c to the 2nd d. I'll just move this over so it looks a little prettier, over 2. My second example, I have the 10 and the 6. I notice both of those have factors of 2 in them, so I'm going to divide that 2 out. The 10 is going to become 5. The 6 is going to become 3. Therefore, I'm going to have a 5 in my numerator, a 3 in my denominator. Then I'm going to move on to the r's. Now with my r's, I notice I have r to the 7th in the denominator and r to the 3rd in the numerator. Since my 7 is larger, I'm going to do the 7 minus 3. But since I started in the denominator, my r is going to remain in the denominator. 7 minus 3 is 4. And again, I think about it, well, if I had 7 r's in the denominator, 3 r's in the numerator, 3 of those r's in the numerator denominator are going to divide out. Well, there's still r's in the denominator. That's why we have r to the 4th down there. And then last but not least, we notice we have this u all by itself. So there's going to have to be a u in our answer of u to the 1st written that way. And we have it simplified. Now this example, I have g over g to the 8th. The piece that you want to remember on this one is, really this is g to the 1st power. So if I subtract, there's 2 ways, I guess, to look at this. I like to have those positive exponents, but I'm just going to show you 2 ways. One way, I could take it and start with my numerator 1, subtract 8. If I do that, I get a negative 7. So that's one way. We could write it as g to the negative 7. Many times we don't do that, and we do it the other way, where we're going to start with our denominator, subtract our numerator, and we'll get g to the 7th. Now, if we do it that way, the thing you have to keep in mind is that g to the 7th is really in the denominator. What's in the numerator? Well, there's nothing left. Technically, there's that factor of 1, so we have to have that factor of 1 there. So you can write it either way. Many times, we're told to have positive exponents, so the red would be better, but this is another way to express the answer. And then last but not least, we have this blue one. Again, I'm going to start with the number part. So I look at this and go, well, negative 28, 16, they both have a factor of 4 in them. This negative 28 then is going to become negative 7. This 16 is going to become 4. So I'm going to have a negative 7 in my numerator. I'm going to have a 4 in my denominator. I move on now and I look at the x's. Well, there's an x here, and that's the only x. Therefore, my answer is going to have an x in the numerator since it was in the numerator in the problem. As I continue on, I'm going to go to the y's. Y to the 5th over y to the 3rd. Well, 5 minus 3 is 2. Since I started in my numerator, my y's will end up in my numerator. So 5 minus 3 is 2, y to the 2nd. And then last but not least, I have the z's. I have z to the 2nd here. I have z to the 6th here. I can take that 6, subtract 2, I get 4. So I'll have z to the 4th. And since I started in the denominator, or another way to think of it is there's more z's in the denominator, start down there, and then I'll have more z's in my answer in the denominator. So when it's all said and done, I have the negative 7x to y to the 2nd over 4z to the 4th. And that would be my final answer. And that will conclude my lesson on using the quotient of powers rule.